I want to introduce you to Peter, who works at GE Digital, and he's a software architect, and he's going to be talking about Edge. And Edge is one of the more interesting topics that sort of is new at Docker, and so I'm very curious to see what you come up with as one of the new workload types is enabled.
Hey everybody, can you guys hear me? Yeah, all right, cool. Well, welcome to the presentation. I'm going to be talking a bit about packaging software for distribution at the edge for Docker and Windows Server. My name is Peter Nye. I'm from GE Digital. We're based out in San Ramon. That's over out there in the East Bay. It's a little bit warmer and sunnier and such, but all right. I'm going to grab the other clicker. Bear with me. No, they don't work. All right, that's cool. A little bit about myself. I want to tell you about who I am before I start talking about this stuff. My name is, again, Peter Nye. I was born and raised in New York City. I went to school in RIT up in Rochester, Institute of Technology. And I've been working in industry for, a lot of years. But I've worked in a lot of different places over across New York City, in Rochester, New York itself, and over here on the East Bay and South Bay, San Francisco, and so on and so forth. The last couple of years, I find myself at GE Digital out in San Ramon. Our initiatives vary greatly all the way to industrial IoT. So it's actually a new industry for myself, but nonetheless, it's fairly interesting. That's my old Facebook profile pic, right? For lack of a better thing, I never knew what to do with it. So after a while, it just kind of resided. That's my email address and LinkedIn address, right? And a little bit about what we're going to talk about today. I'm going to tell you a little bit about what GE Digital does, what asset performance management is, tell you a little bit about what our problem definition is, and then talk about the proposed solutions. I'm going to launch into a little demo. Okay. Oh, it's cool. Thank you. All right. So I figured I can tell you a little bit about asset performance management, and I actually have a little video that I wanted to show you guys. It's actually easier to describe it this way. Bear with me. We have a little
invested in your assets.
Is there sound on the video?
On a massive scale to manage your risk around safety, financial, and environmental.
All right. So I'll just talk through the video. So essentially, this is a manufacturing plant, and there's a lot of bits that are floating up into the sky. So what we wanted to kind of say is that there are assets throughout manufacturing plants that you want to measure. There's pumps, there's turbines, so on and so forth, right? And essentially, the trick is, how do you organize all of this? A lot of the plants, some of them are very manual, right? So you have organizers that essentially go throughout the plant every day, and they kind of go through checklists manually and saying that this is measured this way, maybe this is too thick, so on and so forth. And essentially, it'd be a lot easier if you can automate all that. So there, essentially, what we do is we install sensors on all these different assets. And a lot of the data then just flows up into essentially the cloud or an APM system, or systems that are called asset performance management, right? They tell you a little bit about, so that's a picture of a pump, right? So if it exceeds like a certain temperature and so on and so forth, it automatically launches off alerts, right? And so case managers at the plant know to then go and then take a look into these assets. So that itself is a little bit about asset performance management. And okay, I'll let this play out a little bit because it's kind of cool. I didn't create this video myself, but it's actually out there on the GE site. It's got great theme music in the back as well, but you know. All right. And this basically says that if you had a fleet of manufacturing plants around the world, All this can be gathered together in one APM system, and then you can measure your asset criticality in that manner. Okay. So that is a video. That is GE Digital APM system. So as you can imagine, there's a lot of business benefits from automating all of this, right? I'm not going to read through each one of these stats, but you kind of get the gist of things. And if you ever wanted to look and see what APM is about, we're out there on the net. You could just do a search on GE space APM, and this page will come up. Okay. Now I kind of wanted to talk a little bit about our APM on-premise system, right? We also have a cloud-based offering. We also have an on-premise-based offering, right? And we call that APM Classic. And what's depicted here is a generic component architecture. And this doesn't have any secret sauce in this, but essentially what I wanted to show you was that this is a generic .NET web application, right? So it runs on IIS, runs on Windows Server. That top portion there, the big blue blocks, that's basically end-tier architecture for a generic .NET web application where you have your data tier, your business tier, and your presentation tier, right? And of course, below that, you would have your data stores and caches. And here we're actually using SQL Server and Redis cache. So we're going to return back to this picture, but I wanted you to kind of like take a look at that. Look at this, where essentially this is our on-premise APM system. Now I'm going to show you a little bit about what a manufacturing plant is about and their network topology. So if you did a search on Google, right, and you looked up something called Perdue Model, you're going to see something that looks like this. It's essentially a depiction of what a manufacturing floor looks like, right? The different networking layers. It's really comprised of two separate network zones, right? Levels 0 through 4, or 0 through 3, excuse me, is the OT networks, or the operational technology networks. This is responsible for where all the operations happen in the plant. So if you can imagine a plant like Coca-Cola, right, where you would have one assembly line, right, where the bottles are flowing through, and then it's filling up with soda. That would be one assembly line. Then you have a second assembly line where the bottles filled with soda come through, and it kind of puts the bottle caps on them, right? Each one of those are separate OTs, and they're very locked down because these things run 24/7, and they just don't want anything to take these things down. So the people that actually work in each of the assembly lines, they actually do not have access to the other assembly line. They work specifically in that one OT zone, right? So you would have multiple OT zones in one manufacturing plant. And at the top, at levels 4 and 5, you have your IT zones. That's what everybody's kind of familiar with, right? Information technologies, where you have your corporate intranet emails, right? And you have your enterprise asset management systems, right? Essentially, your corporate staff would have access to that. So those are governed by a separate zone altogether. So you have your OT zones and you have your IT zones. And essentially, where our systems reside, the APM on-premise system, would be in the center there, in that where it says Operations DMZ, in the edge systems. And basically, it pulls data from both OT and IT zones, right? And it helps your staff and case managers and other people basically monitor their manufacturing plants in that sense. So, and here is the problem statement essentially is that whenever we come out with a new release of APM Classic, it actually, what we do is email out a link to say, hey, there's a software update. Can you please install this on your systems? And it usually takes customers like 3 or 4 months to actually finally roll that out. The reason being is because they're also running 24/7 again, right? And so what they do is they take their new software update and they install it onto a QA system, right? A staging system that they have on the side. And they let that run, and they make sure that it's rock solid before they kind of swap that over as being hot production, right? So that process alone actually takes about 3 or 4 months. As you can imagine, it's very daunting, right? So it's very expensive for the customer as well, right? And it's a risk point that we have to address. So essentially, Let me look at my crib sheet here. Hold on a second. Let's see what the next slide is. Okay. So essentially, we wanted to say, how do we kind of make this process a little bit easier, right? How do we package software for the edge, right? How do we do that? So the answer is we containerize our software, therefore making it easier to deploy. Because now we've kind of taken out the dependencies and a lot of the errors that actually happen when things are not containerized. So this is the part of the presentation where a light bulb goes off. And we kind of realized this is our journey, our Docker journey at GE Digital. Essentially was to develop an easier, self-reliant, and portable software deployment process for our teams and customers, right? Incorporated containerization technology. We found that Docker brings about an approach to package software, right? If you kind of read that last statement carefully, it's actually broken down into two parts. The package software and helps enable the deployment of these components to the edge, right? So there's actually two parts to that, right? First is the containerization and then the deployment. Okay, so with this, we've been able to streamline our development to deployment ecosystem, right? Very simply. So starting from far left, I'm sure a lot of us are familiar with this, but an engineer can now create their own Docker images, run smoke tests and so on and so forth, and get very consistent reports or outputs as what QA may have. Our build systems, like Jenkins and stuff, can then also build the same Docker image files, right? These image files can then be distributed for testing to QA, for automated testing and manual testing. These same images can then be pushed into our DTR, right? Our Docker registry, right? Our deployment admin can then actually, utilizing a management console, deploy this to production, or what is known as edge, right? This is the customer's edge. It's an edge system, right? And then have that run as well. So it makes it a lot more streamlined. It makes it a lot more certain. It makes things a lot more predictable. So in industries like manufacturing, that's very important. So this slide, let me go back one. So from deployment administration out into the edge server, it's not as simple as a push, right? Because you can open up port 2375 and push off if you wanted to, right? But actually, that's very seldom the case with customers, right? Because essentially, they've deployed your systems into their corporate intranet, right? And very seldom would another corporation would open up their firewall for you to push stuff into, right? It's kind of, without strict authentication, so on and so forth. They may have different compliances with different industries, right? So essentially, what's depicted here from deployment pushing out to the edge, that's very conceptual. And what I'm about to show you is actually a very different model, right? So our deployment interactions to the edge are actually a little bit different, right? So this is almost mimicking like you're running a web browser inside your own corporate intranet, and you're actually going out and reaching out to Yahoo and getting the latest news and stuff. So you can see it in your own browser, essentially. So at the edge, we have something called an edge agent, right? This thing is continually polling, right? We can configure it to run as often as we want, right? So by default, it's set up to be every 30 minutes because updates don't come very often. But every 30 minutes, this edge agent actually polling out there to a certain endpoint on the net saying, hey, is there any updates for me? Is there any instructions that you want me to do? And usually, no, there's nothing. But if there ever is, such as step 2 over there, where a deployment administrator may want to input some instructions saying, hey, get me the logs. I think something's going on here. Hey, get me this, get me that. Hey, there's a new update to APM Classic that I want you to go retrieve. Register that command. That gets registered into the Edge commands database. And then the next time the Edge agent pulls to what did I call it there? The Edge. These are anonymized names to protect the innocent, right? So then the Edge agent pulls out to the Edge commands controller to basically retrieve the next instruction. It finds something. It pulls down that packet of instructions and it says, and opens it up and says, so what do I have, right? Oh, you want me to get the logs? Sure. And it does something and pushes itself out again. Next time it can actually open up something and says, oh, there's an update to APM Classic. I need to pull down the next image. Where is this? Oh, here's the address, or basically I can pull it down from this DTR, right? And that's step 4, right, where we pull the image down from the GE DTR. And then essentially it pushes the image into the Edge server on a Docker that's running on there, and essentially can then run it as the latest container. And just for the notes, I kind of put a little asterisk on the slide deck. As you know, our Edge systems are very highly secure. There's a whole topic about whitelisting and certificate exchange and authentication, and so on and so forth. But that can go on for like 5 hours and such. But just so you know that it's actually very secure, it's actually out there as well. Just kind of put a little asterisk on there. And if you look at our Edge model, this is basically how it looks holistically, right? It's actually a hybrid between Linux and Windows, right? Environments that can be running on the same server, depending on the footprint of the server, right? So these things can be small as a shoebox as long as it's running like Windows Server 2016, and it can run like maybe just a couple of components, that's fine. But if you have a 2U unit server that's deployed into the customer's data center, it may start to look like this, right? You would have a combination of Linux-based software components as well as Linux-based Docker images, containers that are running, right? You may even have a VM that's deployed on there as well for Windows Server 2016, all right? And within Windows Server 2016, you would have its own Windows programs, its own Windows Docker images, as well as own Docker volumes, so on and so forth. And these two can actually communicate with each other. I've depicted it here very conceptually. I know it kind of depicts I'm not sure if anybody's familiar with hypervisors. It's kind of depicted as a type 1 hypervisor, but it can be type 0 as well, right? So there's not really any strict reliance on that. So for the sake of this topic, I'm going to hone in on Windows Server 2016 in a bit. And for the sake of, I remember the generic component architecture before, we had the .NET web application, we had the SQL Server database, and we had the Redis cache. So here it is again, running on Windows Server 2016. You have SQL Server, right? That's basically off the shelf, with its database files externalized outside of the container, because containers are stateless and you don't want your database to stop and all of a sudden there's no data left, right? You have Redis, which is off the shelf. It doesn't require any volume mounting or Docker volumes, essentially, because once that stops and starts up again, it's a cache. It'll fill itself back up again. And then you have the APM system, which is the .NET web application. And that's the interesting part of this conversation, all right? And now I talk a little bit about how we built the APM Classic Docker image, right? And this is a simplification of the Docker file that you see here, right? And I'll go through it, portions of this, right? I've abbreviated some portions of it, as you can see. So it's based off the IIS image, obviously. We then install some prerequisites, right? That's the second section. And then we do some checks. We look in the registry just to make sure that we got things right. After that, we install some Windows features just on top of the server there, just to make sure that we have all our prerequisites in IIS as well. And then I copy over the programmatic files, right there, essentially for APM. Now, I know I could have mounted it using Docker volumes, but that would have simplified everything. And actually, for the sake of demonstration, that's the nuance that I actually wanted to show you that's really interesting that I found. And then what I do next, essentially, and it's commented out, as you can see, I start registering the .NET web application with IIS. And I commented it out because for some reason, I couldn't get this to work, right? It just didn't work. I was like, no matter why I did Docker build it just didn't register. And then what I did next was really interesting and why I kind of kept it here, right? So what I did next was I intercepted the Docker container. I don't know if too many people have done this. It's actually kind of fun, right? But essentially, I took the built image that I did in the previous step, and I ran it, right? So keep in mind, I have all the prerequisites installed on there. I have IIS all set up. I have the programmatic files sitting there, but it's not registered with IIS. So if I brought up a browser, tried to hit port 80, I wouldn't get anything, right? So what I did was I run the container, run that image, and that's the first part, the first line up there, right? And then I open up a second PowerShell, right? And then I intercepted that container. Basically, I kind of just launched into it. It's like very Inception type of thing to do, I know. But opened up a PowerShell, and then I manually typed in those commands to install to basically install some of the Windows features and so on and so forth, and then to manually register the application with IIS, right? I suddenly had eyes and ears into this running container that was kind of half created before. And I realized, like, hey, I found a great way to basically debug my containers, right? And so with the PowerShell, I have the open PowerShell into that container. I was now able to register the application with IIS, excuse me, right? Of course, containers are stateless, so if you stop the container and remove it, it's gone. You have to do it all over again. So what I did in the last step was essentially, I found out what the container ID was by using Docker PS, right? And then I stopped the container. Notice I didn't remove it, I just stopped it, right? And then I committed it. Basically, what that does is you take that container and you commit it to a new image. I flash frozen, essentially, that container into a new image. So I've kind of automatically built it, and then I intercepted it and I manually registered an application, and I flash froze it into a new image, right? And I just thought it was an interesting thing to share, and kind of was like a light bulb moment for me. So what I'm going to show you next is a video of a demo, all right, of basically the system running. All right. Okay. Let's see if I got this right. Yeah. Okay, a lot of this is in PowerShell, and then essentially a browser. So what I wanted to show you first was I put a lot of the customer's configuration files, essentially, and database files. I externalize it into another drive, right? It's just easier to manage and such, because now your C drive is open, right? And a lot of the data is essentially stored on your, I've noted here as X drive, right? So the top one is essentially their configuration settings, right? This is where, the database server is, what's the database username, password, so on and so forth. The bottom portion is essentially the externalized SQL Server database files. So therefore, if you ever rev the SQL Server image, you're good to go, because you've kind of maintained the data. So here I have a series of scripts. Just wanted you to know that I could have done this all in a Docker Compose file, but it wouldn't have been as fun, right? So essentially, this first step creates a subnet, a Docker network subnet, right? So I've created a subnet. I'll do 168.1.0 through 24. It's running on that gateway, as you see, 1.1. And I've called it APM NAT network, right? And the bottom portion here is essentially the Docker network information. The next thing I do is start up the Redis cache. Right, if you look at this command, the Docker run command, what I'm doing is I'm exposing a Redis over port 6379 externally, right, to the server that I'm running this on, and using the internal port 6379 as well, right? Just happens to be the default port for Redis, right? I'm running this on the Docker network that I just created called APM NAT network. And I've given it a static IP address just for the sake of this conversation. 192.168.1.5. Right, and there you see the Redis container running. Next, I start the database. This one's a little bit more involved, as you can see. I'm, again, exposing port 1433, which happens to be the default SQL Server port, right? I'm actually using it as externally and internally as well. I'm running it again on the on the Docker network, APM NAT network. I've given it an address of 192.168.1.6, right? There are some command line parameters to accept the end user license agreement. And I'm also, as you can see here, I'm also mounting the Docker volume, I'm also mounting the Docker volume, the drive X, as you can see, /APMDB, right? That's exactly where the external files were, right? Those are the database files. And I mounted it into the C working directory within the container. And just to note, you kind of see like the image, the Docker image address there, like 3.5.13. That's essentially our a DTR that I stood up internally inside of GE Digital that we essentially store our images on. This is just internal facing. And again, you see now you see two containers running, one Redis and one SQL Server. Now I'm going to start up the application, the APM Classic application. And again, I'm exposing this on port 80. Again, remember this is essentially an IIS.NET web application, right? It's deployed. I'm exposing port 80. It's running on the APM NAT network. I've given it an address of 192.168.1.7, right? I've also performed some volume, Docker volumes as well, right? This is where the configuration files were that were on the X drive essentially, such as like the database host, where it is, the username, password, so on and so forth. And here you see 3 containers now running. Excuse me. Okay, what I do next is I bring up a browser. Now just kind of keep in mind, I'll stop this right here for a second. I've kind of blocked out certain parts of the screens because I wanted to keep our customers kind of anonymized and such, right? So that's what those white boxes may be, just in case you're kind of curious. It isn't our UX department, it's just me blocking out part of the video. So essentially, this is logging into the APM Classic system. And this is what I look at, right? Also, our URL kind of depicts the customer name in there as well, so I've kind of just cropped that out of the video. And this is essentially our APM Classic system. And you can peruse the health of the assets, essentially, right? Okay. That is the demo. Going back here. So in conclusion, our primary goal was to develop an easier, self-reliant, and portable software deployment process for both our customers and our teams that are working at GE Digital, and to help manage some of these software deployments to the edge, because it can be challenging, right? And we found that containerization tools like Docker on Windows Enterprise Edition has helped enable that for us, right? Because it brings about a way to help us package our software and then essentially deploy that to the edge. I want to thank you very much. Again, my name is Peter and I am from GE Digital, software architect out in San Ramon, California. Thanks. If you guys have any questions and such, I think we have a few minutes left. Yeah.
It's on.
Oh, the
I'll
mic. I have to turn the mic on.
I'm not sure where it is. There we go.
There you go.
So my question is, traditionally, you're talking Windows. When something's in production, has an issue, people would like to remote into the machine, see what's going on with it. And obviously, Docker Windows, there isn't an easy way to handle that. So my question is really about how do you monitor the application? How do you troubleshoot when it's in production?
Right. Essentially, so how do we monitor applications that have been deployed to production that are utilizing Docker for Windows, right? Essentially, so from our deployment administration system, what we do, as I've kind of shown before, that you can essentially deploy instructions, right, to the edge. And I've, through hand waving and such, I've deployed like an application or an instruction set where the edge agent would open up that packet and then say, oh, I got a new image. I need to pull it down from where? Oh, from this DTR. And then deploy that. So along with those different instruction sets that we can send out to the edge, also includes a lot of monitoring and health gatherings, right? So essentially, another instruction set that we do is essentially help me pull the latest logs. Help me pull this latest thing. And current development activities, I'm trying not to divulge too much, but essentially what we're trying to do is make that a more proactive type of scenario, right? Instead of like a deployment administrator figuring, hey, I wonder how those systems are doing over there in customer A. Let me go pull the logs, right? It just happens to be 2 in the morning. They also do on a Saturday night, right? So essentially, just instead of doing that, we can essentially have it report to us, or just have the edge agent start to monitor its own health, and then basically it can kind of report back to the deployment administrator saying, "Help me, something's wrong. Help me, this is going awry. Let me report something out." Right? So essentially, that's the model we'd like to strive towards. I'm sorry? Yeah, I think I... Yeah, sorry.
Have you considered using like WinLog beat and file beats and just ship it to L?
I'm sorry, could you... Yeah.
Have you considered using WinLog beat, file beats? I mean, that's pretty simple to get anything off a Windows box that doesn't have a UI. And then Telegraph for all your telemetry.
Yeah, it's hard to hear, I'm sorry. It's very echoey whenever...
So WinLog beat and file beat to use combined with like Elasticsearch on the back end with Logstash. I mean, that's the easiest way to ship logs of event logs and IIS logs or whatever you have off a Windows box, and then Telegraph to ship any system metrics as well.
Yep, that's right. We are investigating a lot of logging approaches, a lot of products as well. We don't imagine that we're going to handcraft or hand build everything. It's actually wiser not to, right? Especially with the wealth of tools that we have today. Yeah, I mean, kudos. You're exactly right. I just didn't want to reveal too much at this time. But you're exactly right. I mean, that's right, Paul. Sure.
Is the Edge component provided by Docker itself, or did you build it in-house? The Edge component, what you described in this?
I'm sorry, it's really echoey.
The Edge component,
Yeah.
what you had in the screenshot, is it developed in-house or Docker provided it?
Oh, the Edge component. Yeah. Oh, okay. So the question basically is the Edge component developed in-house of GE Digital, or was it provided by Docker, right? The edge is actually running on a specific framework that was developed in GE Digital, right? It's part of it is like the latest incantation of, and I'm trying to carefully craft my words because there's certain things that are released and there's certain things that are in the works. I have privy to both. But if you look on Predix.io right now, today, under resources, and you look around in there, you're going to find something called Predix Machine, right? So essentially, that is a framework that helps facilitate building an edge platform. And in there will be things like the edge agents, among other things as well, right? So that's just one of the components. So the framework that runs on the edge device is actually developed by GE Digital. It's based off of the Predix Machine SDK that is out on Predix.io today. Having said that, we're also working on the latest incantation as well. So it's starting to evolve. It's starting to get really interesting. And the reason being is because Edge itself is starting to get really interesting. There's going to be a lot of players that are coming on board for that. And so that space is really evolving very quickly and very maturely, right? And so there's going to be a lot of features that you're going to see on there, not only from GE Digital, but from other companies as well. You're going to start to see not only diagnostic information that's transmitted back or monitoring or even running things like .NET web applications. You're going to start to see, as compute power grows at the edge and as customers start to deploy on like 2U unit servers and maybe a rack of servers, you're going to start to see a lot more compute power there. So you're going to start to see things like maybe analytics. You're going to start to see a wealth of other features that are there as well. So, okay. And that's where the industry is going.
Thank you.
Yeah, sure thing. All right, yeah, one more. I got the red light from the guy in the back.
Time,
No.
right? So my question is around the edge component again. Can you hear me?
I'm sorry, it's so echoey.
Okay.
You can come up here and I'll reiterate your question. Yeah. Sure. Yeah, so the question basically is, how are we running the applications at the edge, right? How do we manage that? So essentially, that goes along with the previous answer as well. In combination for what you've seen today, essentially, we have a framework that's based off a Predix Machine, right? That helps run and execute our programs that may be running at the edge, right? It has some smarts in there where, like, if certain things stop, it'll restart it again, so on and so forth, right? We have a mix of that as well as Linux-based Docker images, right, that are also running, and so a mix with Windows-based Docker images as well, along with just some regular programs that are just running, right, on top of Linux. Some regular programs that might be running on Windows, right? So we actually have a blend of all those together that are running at the edge. All right, so I wanted to thank you all for coming. I'll be here all week. Just in case, just stop me in the hallway. I'd love to talk. Thank you.